Chapter 6, Section 2, problem number 17. Probably just like 13 and 15, right? But this is an A and a B, so something's a little different. Suppose speeds of vehicles on a particular stretch of roadway are normally distributed with a mean 36.6 miles per hour and standard deviation 1.7 miles per hour. Interesting, so what it's giving us here is the actual population distribution. So this is what the speeds are there that's normally distributed. So our first part A is find the probability that the speed x of a randomly selected vehicle is between 35 and 40 miles per hour. So just any vehicle, grabbing that one vehicle and saying, okay, this is coming from a normally distributed random variable with mean 36.6 and standard deviation 1.7. What's the probability? Our second one, B, is find the probability that the mean speed x bar of 20 randomly selected vehicles is between 35 and 40 miles per hour. Okay, so this is a different probability distribution. So the first one was the speed x, and this is the speed of x bar of a sample. So this is a sampling distribution. First is the actual population distribution. The second is the sampling distribution of a sample taken from that other population. So these will be different numbers. Stop and think about it. So just randomly picking any car, will it be between 35 and 40? You know, 36.6 is the normally distributed speed, so it would be fairly likely. The second one, if I take 20 different vehicles, just randomly select 20, and then take the average of those speeds, the odds are that average is going to be between 35 and 40. There'll be some a little above, some a little below, but they'll average each other out. So the likelihood for B is going to be really high. So that's what we should be expecting on this one. So let's go ahead and look at this then. So A, so this is going to be the probability that 35 is less than or equal to x is less than or equal to 40. And in this particular one, we have our mu is 36.6 and standard deviation is 1.7. So if we do our normal thing like we've been doing in previous problems, here we're looking at 35. We're going to take and transform this to the standard normal distribution. For z is less than 40 minus 36.6 over 1.7. And this is going to give us, let me see, minus 0.94 less than or equal to z less than or equal to 2.00. So this is going to be the probability that z, make sure that's a z, is less than or equal to 2, and subtract off the probability that z is less than or equal to minus 0.94. And we have here 972, 0.1736, so we have 8036. That's pretty high probability. Kind of what we were, well, maybe what I was thinking when I was talking about that a little bit ago and what A might be. B, let's get this one. So this one we're looking again, the probability that, but this time it's of the sampling distribution, which is different than the actual distribution. So the sampling distribution mean is going to be the same. But our sampling distribution standard deviation has that formula again. So we have the standard deviation divided by the square root of, what was our size there, 20? Which is going to give us 0.3801. So when we're looking here to transform this to a standard normal distribution, so 35.5 minus 36.6, we're dividing by a different standard deviation this time. It's less than or equal to z is less than or equal to 40. There we go. So our probability here is going to be minus 1.09. That's less than or equal to z. That's not 1.09. I don't know where that number came from. Let's get rid of that number. It's going to be negative because we've been talking about we had to subtract off a higher mean from the lower part 4.21 less than or equal to z 0.95. So the probability that z is less than or equal to 8.95 minus the probability that z is less than or equal to minus 4.21. So this is essentially 1 minus essentially 0. So essentially, we're completely confident that we will have, out of a sample of 20 vehicles, the mean will be between 35 and 40 miles per hour. Interesting distinction there, how just any one vehicle out of the blue versus if I take a sample and take the average of that sample and the difference between those two concepts. So a key thing we'll need to be keeping in mind as we continue forward here.